Welcome to the January 8th bhyve production user call. We have Andrew Hans, and my browser just crashed or did something or hid itself. Let me try that again. Here we go. It disappeared for me. Just one sec. Welcome to the January 8th bhyve production user call. We have Andrew, Hans, Katya, Jan, Alexei, Roman, and myself, Michael, so far. And here is a question for everyone. libvdsk seems quite abandoned. It is the plumbing to support, say, QEMU and bmdk in bhyve. I ran it by folks like Chuck, who have some interest, but if someone would love to give that some love, I can help facilitate. And in talking to Roman about uh, LibVirt on ARM64, you who are on the call shared something rather cool, which is apparently one can indeed use an Intel host with QEMU ARM64 support and apparently get bhyve guest support. Is that accurate?
Yeah, that's right.
No, but possible it's emulated after all.
Oh, so it's emulated VTX?
So if you have an Intel host for QEMU and you run
Yes,
AMD, sorry, ARM code on it, it's always emulated,
correct.
as in not hardware accelerated.
Right. And for the actual nested dish virtualization, that is just emulated hardware assistance for
No, there
virtualization.
is no hardware
Oh,
virtualization
I
happening at all.
literally just said emulated hardware assistance.
Yeah, there is
Okay.
no VTX used in that case, I think.
Well, they're GIC v3, sorry. They're GIC v3. Okay, cool. So yeah, I want to give that a go and maybe take a look at a D message. Roman, any other comments on that, or what have you learned on libvirt for ARM64 on FreeBSD?
Um, Not much actually. So, well, basically regarding this QEMU command, so I have these experiments going for about a week at this point, and well, I don't really use it currently that much because I'm using the remote system, which is obviously faster, the real
Hmm.
hardware. But as the performance test, I have started build world inside this nested VM, and it's not super fast, obviously. So
Hmm.
after 4 days of running build world, I have the LLVM finally compiled,
Oh,
but
goodness. Okay. Ha.
I'm currently running of the image disk space, so I need to rerun that and wait for another 4 days, I guess. But except that it's running out of disk space, it works fine, surprisingly. So probably it's not that bad. And also 4 days is also, well, um, in my opinion, is also not extremely bad for this.
How many
And
virtual CPU cores
yep,
are you using?
Sorry?
So how many virtual CPU cores are you using?
or like parallel jobs for the build world, dash
Yes.
J something.
Uh, it's
And how many
4.
CPU? Yeah,
Four. Okay.
maybe try 16. Should scale down for the
Hmm.
intensive compilations. So if you have enough CPU cores in your guest, that is.
Right. If you
Yeah,
get
I
the host to
well
support it or whatever, yeah.
definitely need to experiment with that a little more. But well, at this point, it looks like well, it's not super fast, but usable somewhat.
Hmm. Sounds very usable, given that real hardware will struggle like that. So that's great news. So what about libvirt? What blockers have you found on that, and what have you fixed?
So what's currently going in LibVirt regarding the ARM64 support is that I have published the set of initial support patches and they were merged. So initial support will be available in the next release, which is happening, I think, in a week or two or something like that. There are a few things on LibVirt side that needs to be fixed still, and there are some things on the FreeBSD/bhyve stuff side that also needs to be fixed. So the one that I previously mentioned is that I cannot get the CPU frequency, which is well, not strictly required to run VMs, but doesn't really look nice from the management software when it's not supported. And also what I recently learned about bhyve on ARM64 is that it doesn't support VNC, and this also looks like quite a huge limitation. And also, I had a brief email exchange with Haizam regarding Silve and related things, and also he said that VNC, the lack of VNC support is also a relatively huge blocker for him, but yeah. So I guess that's about it. And also, I think on the previous call, I promised to bring up the topic again about the capabilities reporting on the bhyve side.
Mm-hmm.
Uh, I didn't have enough time for that. I hopefully will do it somewhere in the future. Also, I didn't check the approach suggested last time to dump the configuration, but honestly, I have some doubts that it's going to work because it seems like these NVLs that I used to pass configuration across device backends and things like that, it doesn't seem that they use any kind of schema. So I'm not really sure it's going to work like that.
Uh,
But yeah, I'm going through my to-do list and I will get to
oh,
that at some point.
note that from the earliest discussions, the config dump was supposed to be a lower level than any higher level schema like JSON or your YAML or your favorite tool of choice. So I don't know if anyone's produced tools to map those, but that was the initial logic as I understand it. Cool. I've nudged Haitham to join should you both want to discuss that. But thank you so much for looking at that. I do have a bunch of memory for that system if you want to do some scaling tests on Ampere. But yeah, the plumbing is obviously critical. So before we do a little dive into all things, say, PCI bars and pass-through, uh,
I was I was just gonna,
Daniel, Andrew, yeah, who's got some other topics?
well, I was just gonna say real quick,
Yeah, please.
um, not supporting VNC, I definitely agree. That's a pretty hefty blocker for many, many applications.
Yeah, and so it uses U-boot, correct? It's like a payload dedicated to it, if I'm not mistaken. And
I'm not that knowledgeable.
yeah, having documented. So I believe it's U-boot. And the thing is, I don't know if U-boot has any such, be it serial dummy interfaces or VNC or RDP or Spice or anything that would be handy like that. But I do see how, yeah, that's a nice resource. People like to beat up on it and say, hey, VNC is, not encrypted passwords and oh, it's the end of the world, but
Serial
it's sure useful.
serial consoles are fine, Jan, but there are a lot of applications for which they are not the necessarily thing you want.
I'll say options. Okay, well, that's one to investigate. I get it. That's a problem. We it's something you forget how useful it is. So, anyone else? Daniel, do you have anything fun to share? Katya?
Mhm. Nothing in particular on my end for the
Cool.
moment.
Okay, well, let's jump right in. Welcome,
Oh,
Alexei. There was a
okay.
discussion this week of like throwing some stones like, hey, wait a minute, why isn't NVIDIA PCI pass-through working? Which kind of sort of is working for some under some circumstances. But as a
Yeah,
preface to that, it sounds like you've
including
been
the
working
device,
on,
right? I don't know what were they doing to get the PCI pass-through working, like to configure their VM. But as far as I know, to get NVIDIA pass-through working, you need to dump a vBIOS and then trim it using a tool because at the header there is a block of NVIDIA specific code that doesn't work usually in normal VMs. So you need to trim that off, and after that, it should work. when you
Okay.
pass that file into the VM as the ROM bar. Oh, not bar, just ROM of the PCI device.
Okay. So that said, I've seen some chatter about how you've been working on a high performance ROM dump, was it?
Yeah, bar dump.
Bar dump. Thank you. Sorry about that. Yes.
VRAM and other stuff. I've pretty much at this point hit the limit of PC of just regular PCI input output.
Okay.
I'm gonna
Can
try to
you?
share my screen.
Sure. If you want to describe or show that process, that'd be awesome.
Is this working?
Yes, and people, it's now a different tab on Zoom because Zoom
Okay.
does that now.
Okay. So I have the old version. This one is single-threaded. And I have the new version, threaded.c. This one is using pthreads, and it was pretty much a pain in the butt to make.
Okay.
And we also have the good old PCI conf -d. This one is what I'm kind of mad about. If you do PCI conf -d, PCI 04500, that's my GPU, 0x18, that's the bar containing all of my VRAM, and dd off dev null status progress, we're gonna see the speed of it. And the speed is pretty abysmal. It will take quite a long time to dump 16 gigabytes of RAM with this speed. You can do DX, that's to use longer bytes. That's to dump 4 bytes at the same time in each block. This speeds up a tiny bit, but not by much. It's only about 1.7 megabytes a second. And here come my versions. Let's look at the single-threaded one.
I mean, it's twice as fast. It's still painfully slow, but
PCI 0, 4500, 0x18. This is as fast as I could get it with a single thread.
Single-threaded. Okay. 14
PCI
megasecond.
input output without DMA is apparently super slow.
If you do a context switch per 4 or 8 bytes, of course.
Yeah, this is
Have you run this code through
pretty big
Trust?
blocks. This is dumping it in 4 kilobyte blocks. I can make it into 1 megabyte blocks, but it's still going to be limited to that speed.
That block size is more than fast enough, large enough. It's just.
Yeah, it is still limited to 14. And now we have threaded LP threads. Just LP thread. The syntax is the same. There's just n threads now as an argument. 4500, 0x18. Let's pipe this into DD off dev null status progress. By default, it uses a single thread, so it's going to be about the same speed as the other one.
Meg slower, but yeah.
1 megabyte slower. If you use 6 threads, this is the limit.
Boom,
24
24.
megabytes a second is the limit. I could do more threads, but it's gonna just make my PC go slow. I'm gonna open btop. It won't show much info, but
Can you run the command under Trust?
My PC is very slow now, and it's even slower than it was before. So around 4 to 6 threads seems to be the limit.
Okay.
4 threads and get 24 megabytes a second with a lot of CPU usage.
Yeah, Jan would like to see that with truss, and that's just truss in front of it, correct?
Yep.
Are you familiar with the truss tracing tool?
Sudo and the
What is
command.
truss?
It's a system
Sudo
call tracer,
truss.
so that you find out what it does. So
Truss,
so we can see where the bottlenecks are.
yeah, because
let's see.
I was wondering if we see it doing an octal, like
And
crazy or
let's
something.
take a look at this one. There's a lot of write.
Yeah, but where does the data come from? Before
I
you
don't
can write anything, you have to read it. Unless it's memory mapped.
Let's
Then
Gave a
can
PCI
you?
device, no?
period.
Yeah. So
fstat. Yep, it gets the thing, then
so
basically tells it, and then it
okay.
just okay.
I
It
wonder
does
how that
etc.
this works. Where? What
Yeah,
is?
I
Does it
the
truly
limit,
allow
the limit
context
seems
switch
to
free
be
access, or is that memory? Is every memory
it is.
access a page fold?
I don't know what is it on the internals, so I just map the PCI
Mhm.
bar,
Yeah.
like it's over here, and then I just read it. Yep, this is just fwrite.
Okay.
Yep, from base in blocks to start it out, and that's it.
Mm-hmm.
Hans, are you following
And I
along? I
try
know this
doing, even
intrudes
if I
on your
do it in
territory
chunks,
and experience.
in malloc, even if I do it in chunks, it's still very slow.
Mm-hmm.
I've lost track a while ago.
Okay.
Yeah,
So,
Yes.
Okay,
can
so
you
you're
summarize
mapping
it
that
again,
thing.
please?
yeah.
I wonder what the semantics are if you actually get direct access to the memory region. Yeah, but write combining is only important while you're writing. It shouldn't matter for reading, right?
Yeah. Like,
You
this is
should be able to
this
get
is
more than
reading
14
from this.
megabytes of.
Yeah, this is reading from here and writing to a start it out.
I know.
The mem outer here is very much helping. If I change this to mem outer device, this is what is advised, and that is the default one. If I man PCI, if I do man PCI and go to bar map, then we will find this. VMM are uncacheable for control registers, like for control registers bars. VMM are right combining.
Yep.
And default. If for frame buffers, regular memory like bars should be mapped with default. And there's also device, which is used in the PCI conf
Device.
utility for the dumper. If we use this,
It's even slower.
then it's gonna be much slower. And if we don't do truss,
Okay, truss is okay. At that point, it's obvious that it's access. What you could try is you could try the mem copy to temp buffer helps.
yeah, I
So you mem copy into a stack buffer from the mem. Have you tried that?
Yeah, I did try that. Is this the one? Yep, this is the one. Where I copy it over to a buffer.
A stack buffer, which is cacheable. Then you want it only to be a few kilobytes, like 4K or something.
Yeah, this one is the size of a chunk size. So let me just change. Yep, this is 4K.
Okay, that's great. And it doesn't make it any faster to do the copy like that.
Let's see. Let's set it to device. Faster.c. Yep, it is faster than just the regular read. I already forgot from my experiments. It is faster than just regular reading. And if we do write combining, it's gonna be stuck at the regular 14 megabytes a second. I believe so. Yep.
Interesting.
Wait, what am I going to mark www? Is there source?
Does the file support send file?
Support what?
Does the file descriptor support send file? Can you send file from a PCI FD directly to a normal file?
I do not know. I'm I'm pretty new to C. That is,
Okay.
this whole project was me
Send
learning.
file is a system call which directly
Yeah.
moves data or copy file range would another thing to try, but that probably wouldn't work.
Send
Just-
file. Send a
If
file.
it's supported, it just takes a file descriptor for source and destination, another one, and you can ignore the headers and trailers and just, yeah.
A shared memory object.
Yeah.
Auto stream socket with descriptor S. Okay, this might be faster.
It would,
I don't think so.
if it's
It's-
supported, there's a chance that it
Support.
would be one DMA transfer within the kernel or something. If someone took the time and effort to make it fast,
I like to say,
most likely it's just not supported.
Yeah.
excuse me
that's-
that I've lost track
Just take a
for a
look at the
while.
PC.
No
Can
worries.
You know that's not
Can you
needed.
tell me what exactly you're trying to do again? please?
Dump the bar into a file. This is meant
Okay,
to
then-
dump the bar.
Then send file is not going to help you in any way. And what exactly is the problem?
It is way too slow. This is supposed to read over 16 gigabytes in, well, a reasonable amount of time, and the speed is pretty abysmal for that.
Well, you've gotten it from less than 1 megasecond to 24, which is definitely progress.
Okay,
And
Yeah.
here's a question for you. How do you know that this can actually be much faster? Or is just the hardware ROM that is somewhere there a problem?
It's not a hardware ROM, it is the VRAM
Right.
of the GPU.
Oh, it's the VROM, and that's not a ROM?
Yeah, the ROM, this is the configuration of the GPU, the 0x10 bar. If I read from here, then it triggers a bunch of stuff in the GPU and it can crash my kernel. I do not need to read from this, but it has the ROM of the GPU inside. I can fetch the ROM from here.
that's in VRAM. The ROM is in VRAM.
No. And 0x18 is exactly 16 gigabytes, and it is the VRAM. If I load a game, for example, I can fetch the textures, I can fetch my screen and other stuff from here.
Yeah.
Yeah.
But that's not the one you're trying to read. You're trying to read the other one.
Yeah, I'm trying to read 0x18. 0x10 is something that I really do not want to read because it triggers interrupts.
It's also just 16 megabytes. That one would probably be slow because it's configuration stuff.
To read. This one is pretty much the ROM of the GPU.
Can you send me a link to your code?
I can upload it to my server right now.
Oh.
Let me just
Just a question. If you're trying to read from the video memory of the card, do you know for sure that reading from the video memory is in any way nearly as fast as writing to it would be?
It is supposed to be very fast because games read gigabytes per second from it.
Okay.
For like fetching textures.
Why would they read textures from the GPU? It's
or also like stuff like
for certain effects they want to do on the CPU.
Yeah. There's it needs to read VRAM.
Did I read the texture, do something with that and write it back, or how do I have to think about it?
Textures are just how GPU store data.
This can be done through the GPU driver. I'm not using a GPU driver over here. I'm using the direct PCI like controls in the kernel. The GPU driver might have like DMA implemented inside. You can just say the GPU to write its VRAM out somewhere.
Without even looking there, I would say all of this is just memory mapped. So all you're doing is just you're reading and writing from memory in some part of the address.
I wonder how that's
Let him finish, please. One at a time. We've got latency here. Go ahead, Hans.
I wonder how you could possibly accelerate it by doing anything like DMA, because it is DMA. You're reading from one part of the address space and writing to another, and the rest is more or less hidden well behind the hardware of the PCI Express hub and the GPU.
But isn't this first like a program in the CPU, asking the GPU to grab me this chunk of memory, and then it sends it back to the CPU. And then the GPU's like the driver DMA, it's supposed to just like wait, how do you explain it? Let me just remember.
So
Like the GPU itself is supposed to just map a big block of memory,
mm,
like
so
right over PCI,
PMA
big
would
block of memory
copy the
to
data from one buffer to another. What you're
yeah.
doing is you're trying to memory map the peripheral address space into your user space process. What I'm wondering is, does the kernel actually allow you to do that, or does it set up a page with fake unaccessible bit set and then emulate each access so that it can actually validate each access? So
And I
that
don't
every
know that.
time you read that page, you get a page filled, the data is filled, and then it is allowed to resume or something like that.
PCI bus. That's host bridges. How long is this file? It's pretty short. PCI BIOS. Yeah, this doesn't have anything useful. This is for the bridges and buses. Clerks. I have no idea what I'm doing.
Okay, well, you're doing great work, and it sounds like you are indeed hitting hardware limits, and you're definitely making progress on performance.
Yeah.
That's pretty awesome.
So why do you want to read out the whole GPU VRAM?
I pass the GPU through into a VM that runs a game, and then I want to dump all of the game's textures into a file. Also, there is this tool on Linux called Looking Glass.
Yeah, the NVIDIA
Yeah. This
desktop thing.
this uses shared memory, but I wanted to do something similar, but just by directly reading from VRAM. This is basically just display output from the VM, but directly from the GPU. So there is pretty little latency because there's no networking happening. I kind of wanted to do something like this, but I believe this uses some form of shared memory between the VM and the host instead of just reading from the bar directly. Yep, shared memory
So-
segment.
That said, can we just talk about where you broadly stand on handy dandy easy GPU pass-through for various card vendors, notably NVIDIA, AMD, and Intel?
The what?
How is the general state of GPU pass-through in bhyve?
In Intel works out of the box, but Windows VMs not seem to work. On NVIDIA, I've never tried. I do
Okay.
not have an NVIDIA GPU. AMD, very, very strange. Like every AMD GPU has its own quirks in pass-through. And also reset bug, of course.
Yes,
Oh,
okay.
the Intel GPUs have a reset bug, but it's very, very minor and very, very like easily fixable. unlike the AMD's one, which is absolutely painful.
So, do you recall that discussion in October during the summit about the Intel not doing a proper catch-all for I think it was the latest discrete cards that they're not handled correctly? They're given the wrong Intel VT handling in bhyve.
Yeah, that's because it just checks if the card is made by Intel.
Yeah.
If it's made by Intel, yep, sure, we're gonna use the GVTD
So
posture type, which is
there
not
a
supported
patch
by
to
most
address
people.
that? Is there, because it sounds like
Yeah,
hopefully the
the
card
patch
itself has enough
to
information to be uniquely identified. So is there a patch to get that right?
bhyve AMD64. Is it AMD64? How's the folder called? Let me just see the info here. Oh, they changed the layout.
Okay.
PCI.
And the solution was to simply remove the file attempting to get the selection
Also,
right.
there's a solution of just having a list of all the old GPUs that still support the old protocol and checking if the current GPU model is in that list.
I see. So have you had a chance to look at creating a patch to set that straight?
Yeah, I do have it somewhere.
Okay, cool. Well, let me know if you need any help on that from others, and we'll try to mobilize folks.
Yeah,
it was a very tangible issue.
Oh yeah, there's GVTD probe. This is the thing. You'll just add another thingy, but this changed it and seal. And here, class you also like add a device equals. It's gonna be uint 16t, uint 16t device equals read config. SC PCI R PCI conf shell. How is it called? Yeah, it's called device 0x2. And then we just if like for device. Oh no, that's the deal. For I int I equals 0, I less than like size of GVTD device list. You create like you create an array with all GVTD devices in a separate header file, something like this. I++, and then if device if device is not equal to, and it's not equal to GVTD device list. It's like something like this. I'm just making a mock-up. Then we
I won't stop you.
Like bool, for example, boolean not matches. Matches equals 0. Not like actual matches equals 0, and here matches equals 1. 0.
The canonical way would be to initialize the bools to true, not 1, but just true and false.
Matches Xeo. Oh no, matches 0, else and Xeo. That's pretty much how you do it.
Did you hear Jan's comment on the canonical true versus false versus 1 versus 0?
Huh?
If you use a boolean, it would the way you would write the 1 is just calling it true normally.
Oh, wait, true.
And I'd be curious if the code has examples to follow.
Or you have all the other ways, instead of doing it like this, you just initialize the
it's
you have a variable, something like result, you initialize it to NXIO, and you set it to 0 on a match and then return.
True matches false.
Or you just return on a Or
Yeah.
even simpler, you just return 0 on a match.
Yeah. Oh yeah. Just return
and
the
then return NXIO.
This would not allow for any other extensions for this. Actually, you would just have to put any other code you want to add here before this. But yeah,
Maybe throw in a comment about that. Couldn't
And
hurt.
then you don't need the
pretty
variable
much
matches at
all you
all.
need to do.
The compiler is probably yelling at you at
Yeah.
this point
Yeah.
if you try to compile it with an
Yeah, because there's
unread,
no list for now.
you're not accessing the variable.
I do have a patch that I sent to a person over here. Sent. I sent it to somebody from one of the calls. Here it is. Rosenfeld.
This guy.
Yep.
Okay. Hans, who is present? It sounds like you have a newer version of that now as of the last few minutes.
Here is sent.
Okay.
Rosenfeld. Yeah, here it is. This one. This is just the changed one. This is how I did it before. Yeah. Did it even without those, just like this. Yep, if GVT support device equals device, then return 0, else return XIO. Right here. Yep. And here are the supported devices. Skylake, Coffee Lake, Rocket Lake, Kaby Lake, Apollo Lake, Amber Lake, Ice Lake, and Comet Lake. Every other new GPU will not support GVTD anymore. So yeah. Should I? Is sys types already? Yes, sys types is already included. So you don't need this. Yeah. I can probably remove static. Yeah, GVT supported devices. GVTD supported devices.h. Paste it in. Yep, this is still tabs. Oh, I'm not root. Sudo. Oh, also need license. Where's my... Okay, I don't know what just happened. Oh.
Too much.
What did I just do? Okay, I'm not gonna question that.
Okay. Paste buffers are acrobatics.
Yep, this works.
Okay.
This works fine. And now GVTD supported devices. Yep, return 0. And that's pretty much it. That's all you need to do for this.
Okay. Could you make that into a formal review for
Why do
hopefully
I...
Jan and Hans?
This is the older review. Why do I read... this is the old file. Why do I read 0? Like, PCI host... Oh, that's the old... PCI host read config. Let me just man PCI host read config. Is that even a thing? No, that's not a thing. That's probably a part of bhyve or g read config. Yeah, it's PCI pass-through.h. Where is it defined? PCI pass-through.c. Read config. With. That's going to be with 2. Yep, I read the wrong with here. PCI gvtd.c. Yep. Do I make this just a patch right now?
A patch that is either reviewed by mail or by a reviews.freebsd.org would be great.
Git, let me just check GVTD supported devices. Yep.
And I'd be curious if this has changed any in the Illuma source codes, because they might want to pick it up if you fixed it. Looking at you, Andrew and Hans.
Sudo I.
Illuma should not currently do anything with review classes.
That's been bhyve.
No worries.
Git. Let me just create a new tag. Bhyve patch. Okay, I still don't have any commits in the other tags, so in the main branch, so it should work. Well, no, not a new tag, that's the branch. Git add PCI gvtd.c and gvt supported devices. Should I name it? Oh wait, I should also include as a header.
And you can also do an ls-larth just to see if you've modified something else and remind yourself. It's always handy.
gvt.c include gvt. I should probably just name it. Should I name it PCI underscore GVTD or? Okay, I'm gonna name it like
That
this.
looks consistent.
Yeah. I'm gonna copy this. vpci
Yep.
GVTD. Go to this.
Boom.
Git add this and PCI gvtd.c. Oh, that's taking a long time. How do I check for a modified date?
ls-larth is always handy because it sorts it and it gives you human readable sizes, and I live and die by that.
Okay.
So just go to the very end and see what's modified like today.
It's a dot and this. Those two files that I already added.
What's the exact? Do an up arrow.
Up arrow?
Yeah, to the command you just run, the ls-larth, throw a T in there. Yes, boom, and then you see you've modified those just now.
Yep. Okay.
Cool. Great.
That's cool.
It's a handy reminder. Just a
okay. Thanks.
Sure.
Git status is your friend. Git status dot.
Yes, that's also handy.
Status dot.
Boom. It's great to just cross-reference.
Git commit -m.
So normally Git would tell you the whole repository status, but if you give it a
I do not
path,
have Git setup as root. Git setup user.
Yep.
First time Git setup.
It will just complain.
Give you all your settings. That's something. That's the repository settings. That's not it. Username.
Yes. Whatever.
Alexei. Oops, that's not how you copy stuff. Here we go. Core editor, Emacs. Git commit -m bhyve user.sbin/v. That I think that's how you do it. Let me just check cgit.freebsd.org. Source stable 15. What branch am I? Wait, git status. Or is it like what? How do I check the list? How do they list the config? Git config list show origin.
There you go.
14. I have this set to 14. Oh.
But it probably hasn't changed much. So yeah, okay, maybe take a few minutes to poke at that. But,
okay, let me just cp PCI gvtd.c PCI gvtd supported devices. I'm gonna move this to just root. User source. You can just rmref source. Git clone.
Device busy, but
proxy
it's a
chains.
It's a data set probably.
Proxy chains for a proxy. Git for abz.org. A source.git branch reling 15.0.
In theory, you should always develop on main, and MFC from there. Why not?
Okay, let's do branch main. And the depth of about 10, in case I need to roll back to something.
Well, thank you for giving a great tutorial on this inadvertently. And Alexei, how long have you programmed C? In C?
Like a month.
Alrighty.
Maybe a little bit more. Yeah. I'm like just starting to learn C.
You're doing great. I'll let others comment, but I'm impressed.
If you didn't come from a similar language with pretty good speed of taking it up.
I came from knowing basically nothing at all.
Then you have nothing to be ashamed of in that case.
This is one of my.
But it would be good if you.
I did code in Ruby before.
But it would be useful for any reviewer to know kind of that I'm new to C, just so that they give you the right stylistic tips and tricks, like you can do this, you can do that.
Yep. I just learned the number matrices today. Just gonna say.
Oh, cool. Good.
Yeah. Source. Yeah, I'm doing 3D on PlayStation 1 as just programming in C right now. Decided to do something else instead of FreeBSD. User sbin bhyve. Oh yeah, this has the folders that I was talking about. MD64 and ARCH64. MD64. Oh, this has all this PCI-GVT stuff split. And ARCH64. Yep. This all of the architecture dependent stuff. RISC-V.
Yeah, they've been working on that. Yep.
It's
okay,
quite
that's
experimental.
Cool. Yep.
GVTD is not here. MD64, PCI, GVTD. Let's see, this should...
People probably want you to change your file name to underscores only instead of a mix of underscores and dashes.
Yeah, it is like this here.
Oh, there you go. Yep, stay consistent.
Probe. It is checking for like devices. It does have, where is the check? Oh yeah. And if it's not in any of those generations, it's probably still gonna try to do GVTD. I'm gonna compile bhyve from this branch and test it out later.
Okay. Any questions for Alexei as he's blasting into C and device and PCI handling in a month into C programming?
Bull matches. Bull. I don't need the bull. What am I doing? Let's split, edit, grab this. For my own projects, I also decided to go with the Intel C syntax after using the old BSD syntax for quite some time, where you put everything, including the if brackets on separate lines. FreeBSD apparently uses this syntax now instead of this. And I decided to go absolute modlad and go with the Intel syntax. If you have noticed, what they have it as here. The function definition specific, like this. Yeah, I've just decided to go with the Intel syntax because it seems pretty much fine for me. And yeah, just everything on separate lines, not only the brackets, the function definition, including the arguments, absolutely everything on separate lines, even the brackets and structs.
It's wasting a bit of
yeah,
screen
it is wasting
space.
space.
You have the width, but not the height to waste on modern displays.
Yeah.
Have you read the style man page?
Yep, the FreeBSD style does not do that anymore. Yeah, the old BSD style was just for ifs, I believe, just for ifs and fors. And that's what they have in plan, like in 9 front for now. Or right now, I mean. Width of 2. Oh yeah, amazing meme.
You've lived it. I love it.
Wait, is this the okay? Yeah, this is the one. GT supported devices, and now let's just copy over root. Wait, nope. What am I doing? PCI GTT supported devices, and also need to include this as a header. GBT D, not C. Somewhere over here at the top, we just include PCI Intel GPUs. Wait a second, they did.
What, renamed it?
When did they do this? When did they do this? Did they okay, no, what is this? This seems to be a separate, this seems to be already an implemented PCIDs file, but what is this used for specifically? Is this used for detecting the I don't want to have 2 different PCID files.
Right.
So wait, what is it defined as PCI IDs Intel GPUs? Oh, it's this. Intel NL IDS. Yeah, it's this. Intel DG2.
Take care, Jan. See you. Thank you for
PCI
your insights on this.
It's those. It's not used for detecting if it's yeah. Okay, thanks. Where is your signal? Can I add you there?
I can direct you to him.
Okay.
I forget, are you on Signal?
I was. I can install the bug.
Okay, cool. So yeah,
yeah, this we're gonna have. Are we gonna have 2 different PCID files? This one is like the first one is by Intel, and it's just the generations of the GPUs, and the second one is all the supported ones. Oh,
Gentlemen, I need to depart.
cool. Andrew, did you receive my DM about the place to drop
Yes.
those? Great, awesome. Thank you.
I'll drop that a little bit later. Thank you
so much. Take care. Have a great weekend.
that's kind of yucky. Git check out -b bhyve patch. C PCI GVT D supported devices. Status dot git commit -m. And how's the it's just bhyve. GVTD. Let me search for this over here. Import op region definitions. This, wait, no, that's not the one. For graphics, yep, add PCI IDs of Intel GPUs from Linux. I'm gonna just adapt to this because we already have this apparently.
Amen.
Yep. They added the Linux list. It is quite a bit different from what is mine, but I can probably find the arcs here and make it work. I'm gonna do it tomorrow because right now I need to go
You're
to
doing
bed
great.
soon.
You've given the best tutorial on diving into bhyve development that I've seen ever. Highlighted with points about following style manuals from both FreeBSD and Intel and using a Git workflow and all the things. And you have truly lived the meme of how to draw an owl. Like start with like void main and then dump into PCI dumping. That's brilliant. We are down to Katya and Roman and Hans. Others have had to jump or this went over their heads or equally my head, but you are doing great. Any questions for Alexei? Well, if that's been your project of the hour, those two projects, thank you so, so much. You're doing great. Appreciated. Do you have anything else to share?
I don't know.
Okay. I love your I don't knows because they are amazing.
I can share that the Intel's VRAM kind of looks like a Magic Eye puzzle.
Okay, sweet. Stenography or something? Or what do they call that?
No, it's like Magic Eye. I'll show you.
Magic Eye.
It's one of those where you have to look correctly.
Yeah, exactly. This sort of stereo thing. You look real close and you go cross-eyed and boom, stereo something.
Yeah, this is the pattern they used to fill. This is the pattern they used to fill in the VRAM. That is not used to not leak sensitive information if there was something previously in the VRAM, something like textures or like that is very sensitive that you really do not need to. It's pretty much the same. I get a bit confused. If for example, some program allocates a chunk of VRAM over here, adjusts the texture over here that is like super important, has a very important graphics on it, and then it deallocates it, but it's still in over here, the VRAM. So the GPU automatically clears it with this pattern.
Interesting.
Yeah. So if other program on the GPU runs and it allocates the same chunk of memory, it cannot read the stale memory.
Cool.
So yeah, up close it looks like this.
Yeah, well, brilliant. I would love to know their story about creating that pattern if it, if it intentionally derails some step or it's just cool or what. Very cool.
Probably just like some very simple algorithm
wait a minute. Is that an image rearranged? And if you unpack it, it's just picture of Andy Grove or something?
I was wondering. I was really much wondering that.
Interesting.
I was showing it into like Magic Eye solvers, but it just results it does solve, but it results in a grid. Like those things match, and they match up as a grid in the end. You just get
cool,
a bunch of lines. Pum, 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 lines.
That's like an obfuscated test pattern.
Yeah.
Sweet.
It's pretty cool.
Yeah, no, that's that. You are
Very
definitely
cool
under the
info stuff.
hood of that. Any questions for Alexei? Well, how about we move on to other topics that keep up the good work? I'll leave it at that. Very, very
Yep.
cool.
Thanks.
I will replace the current share with just the doc. I've been taking some notes. I hope people follow along for the great C development tutorial within the FreeBSD and Intel frameworks. That said, I'm impressed. That was awesome. Any questions for anyone at this point? I know a few have had to drop off, given that that was deep. And if you've got wish list items for the new year, things like this, and I'm glad I one brought it up too, you just like dove right in brilliantly. Let's just discuss those. Otherwise, Alexei, would you like the honors?
Like and subscribe.